Hello friends, let me welcome you all to our lecture series on the subject internal combustion engines and gas turbines. Today in this series we will be discussing about the combustion in compression ignition engines. After learning these topics, it is expected that students should be able to answer the following questions. 1. What are the requirements of combustion in CI engines? 2nd, explain the process of normal combustion in CI engines. And 3rd, explain the different stages of combustion in CI engines. So let us start. So initially we will be discussing about the process of combustion in CI engines. So what is basically combustion? Combustion is basically burning of a hydrocarbon fuel in the presence of oxygen from the air to produce the products like carbon dioxide and water, and obviously liberating heat, which is supposed to be used for producing work. In order to happen this particular combustion properly, there are some requirements which are needed to be satisfied in case of CI engine combustion. And what are they? So the first, we should understand that this is a CI engine, that is compression ignition engine. That is, the mean for combustion is compression. So that means there should be hot air present inside the combustion chamber before we are allowing the fuel into the combustion chamber. That is where generally we use sufficiently high compression ratios, above 16:1. We use the compression ratios depending on the different designs of the engine. We have now made available hot air inside the combustion chamber, and the temperature of the air should be such that it should be above the self-ignition temperature of the fuel. That is where we call it as compression ignition engine. Obviously, there should be some mean for introducing the fuel into the combustion chamber, and whatever we are going to produce is a heterogeneous mixture now. So we have now a heterogeneous mixture of air and fuel. And in order to produce this particular heterogeneous mixture inside the combustion chamber, we have what we call as a fuel injection system. And this fuel injection system consists of a fuel injection pump and an injector system. So the fuel injector pump is going to inject the fuel into the combustion chamber with a high pressure, and the injector is going to ensure that the fuel which is coming from the fuel injection pump with a high pressure is going to be injected in the form of droplet into the combustion chamber, so that we can produce a heterogeneous mixture. Third requirement is we should have a sustained combustion. So here the role of the combustion chamber and the type of injector used, depending on the type of combustion chamber, is playing an important role to ensure that a sustained combustion is happening inside the combustion chamber. Obviously, the air and fuel present in the combustion chamber also has to be utilized to an optimum level. And for this, it is very important to have a proper injection duration. The rate of injection should be in a proper manner, and there should be sufficient air motion inside the combustion chamber to ensure that all the air and fuel is going to be consumed. So these were the requirements of a combustion chamber. Now let us move on to discuss how a normal combustion happens inside a combustion chamber of CI engine. So as we discussed, this is a compression ignition engine, and here we have a heterogeneous mixture which is going to be burned in a very controlled manner inside the combustion chamber. So initially we introduce air into the combustion chamber, and this particular air is going to be compressed during the compression stroke. And as we know, during the compression stroke, the piston is moving towards the top dead center. So as the piston is moving towards the top dead center and it is nearer to the top dead center, at a certain instant here we inject the fuel. So fuel is injected at the end of the compression stroke, and this particular fuel is going into the combustion chamber in the form of droplets, and this particular every droplet is going to burn independently in the combustion chamber. So unlike we had a homogeneous mixture in SI engines where the complete homogeneous mixture was burning with the same flame, here every droplet is burning independently. So that is the basic difference between the combustion in case of a CI engine and SI engine. We have to ensure that the air motion is there to ensure that all the droplets are going to burn in a complete manner, and obviously the duration of injection should be according to the requirement of the power from the engine. That is, when we want more power we have to inject more fuel, and when we have to have less power we have to inject less fuel. So by controlling the injection duration we are able to control the amount of power developed by the engine, and all these things are going to happen in 4 stages as shown in this particular figure. We can say 1, 1, 2, 3, 4. 4 stages have been shown over here, and in this particular 4 stages, your normal combustion is going to happen. So now let us discuss what are these name of this particular 4 stages. So the different stages of a CI engine combustion are: first stage is ignition delay, and the ignition delay is from A to B. Point A to B indicates the ignition delay period. B to C indicates the rapid or uncontrolled combustion happening inside, which is the second stage of combustion. In the third stage is called as controlled combustion stage, and that is happening between the points C to D. And after D, we have the fourth stage, which we call as afterburning stage. So in all, we have now 4 stages, that is ignition delay period, uncontrolled combustion stage, controlled combustion stage, and afterburning stage. So the combustion in CI engine is going to happen in this particular 4 stages. Now let us see one by one what are the different stages. So the first stage, what we call as, is the ignition delay, and it is between A to B. So this particular A to B, A corresponds to the start of injection and B corresponds to the start of combustion. Whatever is happening in between this two is what you call as ignition delay. And what is happening, you can see over here, this particular ignition delay period is being divided into 2 parts. What is happening in this particular D phase? In the D portion, it is called as mixing period. So the fuel and air is being mixed. So this is a mixture formation stage. And this E is the interaction period, or ignition is happening. This delay period is now being divided into 2 parts. One is a mixing period, which we call as physical delay period, and we have the interaction period, which we call as chemical delay period. Basically, we have now the ignition delay, which is being divided into 2 parts. One is a physical delay and chemical delay. That means physical delay period and chemical delay period is equal to ignition delay period. Now, what is happening in this particular 2 sub periods? That is, first, physical delay. So we know that fuel is being injected in the form of droplets. This droplets is moving into the hot air inside the combustion chamber, which has been already compressed to the extent of very high temperature. Obviously, the fuel droplet will not burn as it is, because we know that for any fuel to burn, an inflammability limit is there, and it is going to burn within inflammability limit only. So we have to ensure that this particular fuel, which is going inside, which was coming in the form of like a flow, but due to the pressure with which the fuel is being injected and the resisting pressure inside the combustion chamber, high pressure of the compressed air, this flow is being broken up into small particles, that is, it is atomized. So this atomization has to happen. And for what purpose we are going to atomize? We want to increase the contact surface area between the droplets and the air, so that all the fuel molecules are now available with the sufficient amount of heat which is present in the combustion chamber. So since the surface contact area between the fuel and air is increased, now the fuel can absorb more heat and it can vaporize. So the fuel, every droplet on its surface is going to vaporize, and the vapor whichever is formed is going to mix with air, and that is going to reach self-ignition temperature in order to burn. So this physical things are happening, that is, fuel is being atomized, it is vaporized, it is mixed with air to form a air-fuel mixture within the inflammability limit, and this mixture around the droplet is now reaching the self-ignition temperature. So all these things are happening in the physical delay period. So this is your physical delay period, and all these physical things are happening. Now, since the air-fuel mixture around the droplet has reached the self-ignition temperature, now wherever the mixture is within inflammability limit, it starts burning, and slowly this particular flame which is started at a particular point around the droplet is propagating around the complete surface of the nucleus, somewhere forming around the droplet, and the flame completely engulfing the droplet is what we call as the chemical delay period. And what is happening? The chemical reaction or the ignition is happening for every droplets whichever is available in the inflammability limit. So now here we have what we call as chemical delay period, and this physical delay plus chemical delay is what you call as the ignition delay period in case of CI engine, which is our first stage of combustion. So these all things things are happening in CI engine, first stage of CI engine. What is happening? We are injecting the fuel, atomized, it is vaporized, mixed with air, air-fuel mixture reaches within inflammability limit, then it's increased its temperature, reaches self-ignition temperature, chemical reaction starts, that is burning starts, and now the droplet is being converted into a burning ball. This all things happens in what we call as the first stage of combustion, that is ignition delay period. Now let us see what is happening in the second stage of combustion. So the second stage of combustion is uncontrolled combustion stage B to C. So the uncontrolled or rapid combustion stage, that is what is happening at B. At B, your combustion curve is departing from your motoring curve, that is your combustion is actually starting, it is showing its effect. And what is the C point? C is the point where your peak pressure is reached. So period between the B and C, we can assume that combustion has actually started, and the point between where the maximum pressure is attained inside the combustion chamber is your second stage. And what is happening in this particular stage? During the first stage of combustion, that is ignition delay, every droplets which are coming into the combustion chamber has now reached a stage where it is burning. The surface has started its burning. Now all the accumulated fuel suddenly auto ignites, the temperature and pressure suddenly rises, and you can see the steepness of the curve from B to C, it is very high. Why? Because suddenly all the fuel is going to auto ignite. Whatever the droplets which has been injected in the first stage is now going to burn completely in the second stage, and therefore a maximum pressure point is being attained. And by the time the TDC has reached, and the piston is going to start moving away from the top dead center. This all things happens inside the combustion chamber in case of uncontrolled combustion stage. Summarizing what is happening in the second stage, whatever fuel was injected in the ignition delay period, that is the first stage of combustion, is going to auto ignite suddenly, and therefore peak pressure is going to attain inside the combustion chamber in the second stage, which we call as uncontrolled combustion stage. And since we don't have a control on what is happening in this particular stage, we call it as uncontrolled. Why it is uncontrolled? Because whatever fuel was accumulated is going to burn. We don't know what is the fuel going to be accumulated. It depends on what was the ignition delay period. So that is where we call it as uncontrolled combustion stage. Now let us move on to the next stage, that is the third stage of combustion, and it is between C to D. This particular stage is called as controlled combustion stage. Now what is this particular C? Point C is point of peak pressure, and D corresponds to the point where almost all the fuel is going to be injected and it is going to burn, and a maximum temperature is going to reach inside the combustion chamber. And thereafter, since the piston is moving away from the top dead center, the pressure is going to reduce, but the temperature is going to increase because the more and more fuel is going to be burned, because we are going to inject further. This will be continued till almost all the fuel is going to be burned and the maximum temperature is reached inside the combustion chamber. So basically what is happening in this particular stage? We know that the temperature and pressure inside the combustion chamber is very high, because suddenly all the fuel has been ignited in the second stage and we have reached a maximum pressure and a very high temperature also. Whatever we are going to inject now is going to burn, because the atmosphere inside the combustion chamber is very conducive for burning, and therefore all the fuel is going to burn without any ignition lag. That is, with a zero ignition lag. The instant it comes in the combustion chamber, the fuel droplet is going to start burning. And therefore, what is happening is your rate of injection is going to be higher, then the curve may go like this. If your rate of injection is going to be lesser, then the curve may go like this. That is, now we have a very good control on this particular curve. That is, amount of pressure going to rise inside the combustion chamber, because we know that whatever the curve is going to be there, that depends on whatever amount of fuel is going to be injected into the combustion chamber, and depending on how we control the injection rate, we are going to be able to control the pressure inside the combustion chamber. So that is where we say we have a very controlled fuel injection, and by controlling the fuel injection, we are able to control the pressure inside the combustion chamber, and therefore we say now whatever fuel is burning is in a controlled manner, and therefore at this end of this particular period, injection is going to end and the maximum temperature is going to attain because almost all the fuel is going to be burned. Summarizing, what happens in the third stage? In the third stage, we have a very controlled nature of combustion. The amount of heat generated in this particular stage is going to be depending on what is the rate of injection, and depending on how we are controlling the rate of injection, we are going to get the curve to lesser steeper or higher steeper. So that is where we say this is a controlled combustion stage, and that is the third stage of combustion. Now let us see what happens in the fourth stage, which we call as afterburning. So afterburning starts as a point D where the maximum temperature has reached, almost all the fuel has burned and maximum temperature has reached. Now what happens in this particular stage? Even though we say almost all the fuel has been burned, in some pockets here and there, some fuel was unable to burn because even though sufficient temperature is there, this fuel in the CI engine is going to burn in the form of droplets. Whenever the fuel burns, the droplet is getting covered by the burned gases, and unless we remove this particular burned gases from the surface of the droplet, the inner fuel is not going to burn. And therefore, in order to burn this particular inner fuel, the specific air motion is imparted to the gases. That is, we make this particular gases move inside the combustion chamber in a specific manner. This particular burnt gases which have been enveloped on the droplet is going to be removed, and now the unburnt fuel is landing in the region where sufficient oxygen is there. And whenever this particular droplet is now able to get sufficient oxygen, it is going to burn. And that is where whatever some droplets here and there are going to coming into contact with oxygen, they are going to burn. But since the piston has moved away from the droplet center, even though the fuel burns, it is not going to contribute in the power generation. And therefore, this particular stage, what we call, is called as afterburning. And it is not possible always that every droplet is going to get sufficient oxygen in the combustion chamber. Many times, so the afterburning may continue in the expansion stroke. Many times some fuel droplets even may not be able to burn in the expansion stroke, but they will come out of the combustion chamber after the exhaust stroke, and they may burn even in the atmospheric air whenever they come into contact with the oxygen of the air. These are the things what are generally happening in the fourth stage of combustion, which we call as afterburning. So what happens in the afterburning stage? Some fuel droplets which are unable to burn due to unavailability of the oxygen preferably are burning whenever they come into contact with oxygen, either the oxygen from combustion chamber or from the atmosphere. So that is what is happening in the fourth stage. So thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription, you can press the bell icon to never miss the notification regarding our new video.